I'm Kylie.
And I'm Amanda.
And we are going to describe the process of cellular respiration. So starting off, we're going to talk about the aerobic pathway, which takes oxygen to create energy. And with that, we're starting off with the glycolysis, which is the breakdown of glucose. And you start off with a negative, and it takes 2 ATPs to convert with 2 ADPs. And it converts it and separates the PGAL, which is 3 PGAL and 3 PGAL, 3 electrons. And to create pyruvic acid, it takes NAD plus and converts it into an electron carrier, which is NADH. And then with 2 ATPs and 2 ADPs on this side and on the other side, it cancels out and creates 2 ATPs, 2 NADH, and 2 pyruvic acids.
So then we're going to move on to the Krebs cycle, which is also the citric acid cycle, whatever you want to call it. And you're starting off with the pyruvic acid. And what that is going to do is it's going to cycle in with the CO2 and the hydrogen, the H2. And you're going to keep cycling into like compounds. And that's going to go around. And you're going to end up with NADH2 and FADH2, and that is that process. And then you're going to go to the mitochondria, which is also a part of this whole thing, that is going to make you end up with 32 ATP, which adds up with that the 2 from the glycolysis and the 2 from the pyruvic acid. And then you're going to have 32 from the mitochondriac. And what that does is you have H plus, and those like cycle through for a pump, and it creates oxygen, O2, and then creates H2O, which is water. And they pump H2 through, turns ADP to ATP. So the ADP turns into HTP from the pump of H2. And so that makes you end up with 32.
Okay, and so anaerobic, basically, it does not need oxygen. What it does is that if you don't have glucose, or you get rid of the mitochondria, or don't have oxygen, so that's considered as anaerobic. So the pyruvic acid basically converts into lactic acid, and what that lactic acid does is it freezes the NADH, which is the electron carrier, and it stops it from getting more energy.
The end.